that programmatically anyway, right? So in this way, you can ensure effectively that all 4, or really all 6 of these queries are executed all at once or not at all. You won't get your database into some inconsistent state. So what's the takeaway here? Anytime you have tables, especially multiple tables, where you might need to update 2 things at once. I need to remove some money from this person, add some money to this person. The problem is that, again, if those same rows are touched by a different thread, whether accidentally or maliciously by an adversary trying to create this race condition, you don't want to end up giving someone more money or less money than they're actually owed. So let's go ahead and let's see if we can see this here. Let me go into the appliance. Let me SSH to, all right, here, Crimson. So MySQL-U, jharvard-p, jharvard_lecture2. All right, so now I'm logged into the database at a blinking command prompt here. And let me go ahead and open up a second window. We'll move it over here, SSH to the same system. Let's do MySQL-U, jharvard-p, jharvard_lecture2, Crimson. All right, so now I'm connected at a MySQL prompt. So this is essentially like the non-graphical version of phpMyAdmin. So let me go into phpMyAdmin. And just for the sake of discussion, let me go ahead and create a table called, let's say, cache, and 2 columns. So this will be the user ID, and this will be the amount of cache that he has. So we'll just do an int. We'll do a decimal, which a decimal, recall, is a very precise number. It can have, let's say, 65 numbers and 2 numbers after the period. This will be a primary. And this will be, whoops. OK, so now I have this cache table. So now, if unfamiliar with the command line, notice that I can do the following. Show tables, semicolon. This shows me exactly what's in my tables. If I do, let's say, select star from cache, I get an empty set. So suppose I want to do this. Insert into cache, let's say ID cache. Let's say user 1 is going to get, let's say, $100. All right, and then user 2 will get $200. All right, so now select star from cache. OK, so that's correct. And now let's go ahead and do this. Start transaction, semicolon. If you see the arrow, it means you forgot the semicolon, like I just did. All right, so now let's go ahead and say update cache set cache equal to, let's say, how do I want to update this? Let's go ahead and cache equals cache minus 100, where ID equals 1. But meanwhile, that thread got suspended. So my alt-tabbing is equivalent to that thread being put to sleep for whatever accidental operating system reason. So now I'm going to go here and just do select star from cache. All right, so that's good. So now let me go ahead and do update cache set cache equal to cache minus 100, where ID equals 1. So what is this? You can think of this as the Bank of America's implementation of their ATM. Right? I'm at an ATM. When I say give me $100 out of the machine, and after typing my PIN, this is the query maybe that's executed. By default, queries in MySQL are auto-committed. So we've had this notion of commit all this time. It's just they've all happened automatically. Every query is auto-committed. But if I do this now, it is indeed executed. So now select star from cache. And he has $0. So now let's go over here and hit enter. OK, so that's good. Select star from cache. So this is the other ATM machine, if I'm kind of like tag teaming on 2 different side-by-side ATMs here. OK, that's bad, right? So that should not have been allowed to happen. But hopefully, if Bank of America implemented their ATM correctly, they have executed, after the update, a select, doing a sanity check. Has it gone negative? Because if so, damn it, we don't want to give this guy his $100, so we better not commit this transaction. Let's instead do roll back. OK, now let's reselect the table, and it's back to 0. So even though that was a simple 1 query, we could have rolled back a dozen queries in this way if we wanted to. So any questions on what problem we're actually trying to solve here with transactions? And for those who don't want to raise their hand, oh, yep. Sure. A good question. So CodeIgniter does support transactions by way of a PHP method call. To be honest, your TF might disagree. I am underwhelmed by CodeIgniter's MySQL or database library. To me, it's just rewriting what is raw SQL queries anyway. Frankly, I think doing something like this is very reasonable in CodeIgniter, where you do your own SQL queries in the actual query method, and in this way could you then execute begin transaction yourself, rollback yourself. So you can use the MySQL library. I've just been unimpressed with it. Doesn't really do anything for me other than force me to learn their syntax. Plus, it's easier to express, I think, more sophisticated SQL queries if you're doing it yourself. Other questions? All right, so PDO. So on top of what CodeIgniter is actually doing is, even though we configured it for a MySQL database, it actually can support any number of databases. And MySQL is just one of them. Could use Oracle, could use Microsoft Access. And that's because CodeIgniter does not use MySQL underscore whatever. All of those functions we've typically used in CS50 are obviously tied to MySQL as per their names. But this isn't the best design, right? If your website's getting popular and someone decides, well, we really need a bigger database, although frankly MySQL does scale quite well, but someone decides that you need to change the database backend, it's kind of unfortunate if you have to go through and change all of your function calls throughout your entire program just to change your database. So a recurring theme already in CSS, in today with views and whatnot, has been abstracting away some of these details. And so PDO is actually the library used underneath the hood in CodeIgniter to create this abstraction library. So what does this mean? PDO is portable data objects. And this just means it's a more generic library that has support for fetching data, for selecting, for inserting, for updating, for transactions, but it's independent of MySQL. It converts the commands to Oracle or to MySQL or to whatever database backend you're using, so that you yourself don't have to worry about this ever in the future. And frankly, you can also then avoid the horrific function names like MySQL real escape string. Moreover, with libraries like this, CodeIgniter and in turn PDO, all that crazy stuff we did do in 50 with MySQL real escape string, you can forget about, because all you have to do is call a prepare method, for instance, and any variables you pass in, CodeIgniter or really PDO will automatically escape for you, which is a huge boon for security because you no longer have to remember yourself. The library does it all for you. So this is a super simple example of PHP code you might use in your own applications. CodeIgniter does this for you, so you don't need to go paste this into Project Zero, but it boils down to this. A data source which is in this case type MySQL. The database name is jharvard_lecture, semicolon, host equals this. And 127.0.0.1 is the IP address of most any server by default. This is an ugly, cryptic looking string, but it's just convention to pass this in, and the PDO library will parse it. Then we have username, password, and then there's this notion. We'll come back to this before long, but for those unfamiliar or less familiar with exceptions, it's a way, again, as we discussed a week or two ago, of passing error messages back that are not in the form of return values, but this gives us ultimately what we'll call a database handle. And with that database handle, can we then actually execute some prepared statements as follows. Let me go ahead and just pull up, for now, a simple text editor, just to paint a picture of something we'll see before long in more detail. You can do things like this. Statement gets database handle. That's what DBH is often short for. Prepare, let's say select star from table where ID equals question mark. And what you can then do here is statement bind value, and what you can do is 1, comma, and then ID. So suppose for the sake of discussion that $ID is the user's ID in question. What you can do with this bind value is bind to it whatever question marks were in your original query, the MySQL real escaped version of that variable. So moreover, there's another reason, because obviously this already feels like a little more work than we used to do with MySQL. What else does this do? Well, the upside of prepared statements for performance is that if you're using a SQL query in a loop, as you might be for Harvard courses, querying course after course after course or something like that, and you're executing the same query again and again, what the prepare statement, prepare method does is it essentially pre-compiles that query. Or rather, it tells MySQL, I'm going to be calling this this same exact query, differing only in terms of one or two values again and again and again, please optimize for that. So that on each subsequent execution of that same query, it's much faster than it would be otherwise. So these are generally known as SQL as prepared statements. And you don't need this cryptic numbering. Unfortunately, it's one indexed. It's not zero indexed. This is a little cryptic, I think. So more compelling, I think, is to use colon and then something like ID. And then what you can do is this. You can ditch the whole binding manually, and you can instead do this. You can execute that statement, passing in for any of these name parameters something like this. So you pass in an associative array that then maps values to the placeholders that you put in. So if you think back to %s in printf, colon whatever is now the new